Okay, Justin, can you hear me?
Yeah, loud and clear.
All right. Well, I think we're going to go ahead and start. We are being recorded, and we are streaming this, so we'll just go ahead and start. And first, we want to welcome those who have joined us today. My name is Steve Barry. I am in the admissions department at Old Dominion, and I'll be moderating. So if you do have any questions and you want to place them down in the Q&A section, I'll check those out, and then at the end of the presentation, we'll save a few minutes at the end. We'll go through some of the questions and give Justin a chance to answer. So let me introduce real quick Justin Mason. Justin's going to talk today about at-home astronomy. Should be a fascinating discussion. He's got some great simulation software to show us. Justin joined ODU in 2012, where he started as an academic support coordinator for the physics department. In 2015, he became ODU's director of ODU's Pretlow Planetarium. And you can find him many times at the planetarium, giving shows to the public, summer camps, and local school field trips. While here at ODU, he has earned several awards, including the Rookie Staff Member of the Year in 2013. He received his MS in Physics from Ball State and an MS in Astronomy from Indiana University. So I think you're in for a great presentation, and we'll turn it over to Justin.
Hi, everyone. Welcome to today's presentation. Again, I'm Justin Mason. I'm the director of the planetarium here at ODU. Coming to you today from home, just with the storm coming through, kind of wanted to beat some of the rain, so I'm kind of working from the spare room today. So please don't mind any mess I have back there. Didn't get a chance to clean before this. I was just trying to, again, beat the storm before it comes through today. And so, again, just a little bit about me. I grew up in Indiana. That's why I went to Ball State University. It's where David Letterman went. And then I went to Indiana University for my grad school in astronomy. And so I spent most of my academic career at Indiana, and then got a job opportunity with the physics department at ODU, and then started working for their planetarium as well. And then the planetarium director, he decided to retire. And so since I had been working there and I have a background in astronomy, I'd been working at planetariums as a graduate student as well. I was kind of the logical person to end up taking over. And so I took over around 2015. And then we have a whole new planetarium that is opening up. I was hoping to get to show that a little bit off today, but I didn't get some things recorded that I wanted to record. And so the new planetarium we have is a little bit bigger. We have phenomenal simulation software that we use called Digistar. So what I'm going to do today is show off a program called Stellarium. And so what I'm going to go ahead and do, I'm just going to go ahead and switch over and show off this program some. And then afterwards, I'm going to switch to an infrared camera and talk about infrared astronomy and kind of what we can do with infrared lights. So let's go ahead, and I'm going to share a program called, there we go. Hopefully we can see that. So this is a program called Stellarium. It's like the word stellar with IUM at the end. Let me see if I can show off the name of it here. Yeah, Stellarium, and then version 21.1. This software has been around since about the year 2000. I think around 2006 or 2007. A company from this ended up splitting off to and doing another project that they now sell planetarium software and planetarium hardware. And so our previous planetarium, the Pretlow Planetarium, which just recently closed for our new one, we used the software that was based around this. And so this software is completely free, which is what's great about it. And it's open source too. So I think you just visit, I think it's stellarium.org, or just Google search the word Stellarium, and it'll come up, and it's completely free. And so I wanted to show off kind of how you can use this at home to see what's going on, in the nighttime sky. We can go backwards and forwards in time. We can see what constellations were up on, say, your birthday, or another special day to you or a family member. Or if you get home, someday, you get home from school or get home from work, and oh, what was that object that I saw really bright in the eastern sky, at night? You can go in with this software and go figure out what it is. So I wanted to show off a little bit of what this can do. So I'm going to start off right now. We are looking south in the software. And so I just kind of wanted to show around a little bit. The ground here is not real. It's all the simulation. It's a photo taken probably somewhere in a field that they just edited and then added to the software. So those houses and trees, I don't actually have a camera set up near those. It was a one-time picture. I can change that horizon to be a bunch of mountains or out in the woods. I can kind of go to the moon if I wanted to. It doesn't really matter. But you can see our cardinal directions. We've turned northeast now. And I'm going to start us off kind of facing south, just so you kind of get an idea of what's going on. And all I'm doing, if you do download this in the future, I'm just clicking and dragging it, moving around. We can look up more, see if we can go over and try to find, where's our sun at? Should be pretty far. There we go, because we're pretty late in the day. It's pretty high in the northwest quadrant up there. So there's our sun. And I mentioned you can go anywhere you want. So if I go to my location window, there's a little arrow here that shows me where I'm at on the planet, and I can just kind of click and go anywhere I want. You can see the sky changes with me. I can go to the southern hemisphere, doesn't matter. I can go search for a city. So if I'm going to search for, say, London, see, it should come up. It actually didn't come up. Let me just go back to Norfolk. There we go. So I can click and go wherever I want. I can put in specific latitudes, longitudes, whatever elevation I want. If I go to Denver, I can change the elevation to whatever the elevation of Denver is. Its nickname's the Mile High City, so I want to put in a little bit different elevation than I would here for Norfolk. And then you can change all kinds of things like what's your time zone and add to the list. So if you want to add in like a specific location somewhere, you can add to it. But then the next thing you can do is we can go, let's say, the date and time. So I can change to whatever year I want. And this program is pretty powerful. So what it does, and people ask me this all the time, is how can you go into the future with software like this? Well, we've been able to plot the positions and orbits of planets for a few hundred years, even though we didn't understand the orbits until 1600s or 1700s with Isaac Newton and Johannes Kepler. We didn't understand that they were traveling around the sun rather than traveling around the Earth, geocentric versus the heliocentric model of the solar system. But we still were able to kind of figure out the orbits over time. And so this takes the orbits of the planets in the past and predicts where they'll be in the future. Now, is it 100% accurate? No, because the orbits do get disturbed a little bit as gravity from the other planets does shift them a little bit. But this is pretty accurate to within, sitting at home doing kind of amateur astronomy this way. I mean, if you wanted to use this software to, go land something on Mars, I would go talk with NASA and not rely on this software necessarily. But it is pretty accurate, though, especially just going, a few years in the future. But it can go thousands of years in the future and predict where the planets will be in the sky, what phase of the moon is going to be up, and where the constellations are. So I'm going to leave it for today's dates and the proper time for right now. And that's also shown down here at the bottom. So it shows me my date and time. And so as I start fast forwarding here in a little bit, keep an eye on this little clock down here in the bottom left, I guess kind of bottom center there, because we'll see that start going faster and faster. There is all these little options, and we'll go through most of these and I'll show off what they do. But I'm going to go ahead and let's fast forward to nighttime. So if we're looking southwest, we know we need to at least look west. Everything rises in the east and sets in the west because the Earth rotates counterclockwise when looking down to the north. So let's see, from here, I'm going to go ahead and start fast forwarding time. And so each time I click this button, the passage of time increases by a factor of 10. So right now, I've clicked it once, we're going 10 times faster than normal through time. Click it again, our clock runs faster. We're going 100 times normal speed. And if I click it again, there's 1,000 seconds running in the software for every second we watch the simulation. You can kind of see our moon setting there. There goes our sun. And I'm going to slow it down as we get closer to the sunset here. There we go. And if you notice, the sun did set kind of north of west. That's because we're in the summer months now. We're a little bit past the summer equinox, or sorry, summer solstice. So the sun does set pretty far north of west right now. All right, before too much else comes out, a little bit north of west, not long after sunset, which if you do live like the Norfolk area, sunset here is this time of year, it's about 8:15, 8:20, maybe a little bit sooner than that. And so not long after sunset, there's going to be one really bright object off of the northwest. And so if you remember how many planets there are, we have 8. I know some people still like to count Pluto as a planet. They like to say 9, but remember, it's been since 2006 whenever Pluto was reclassified and kind of, I don't want to say demoted, but it was reclassified as a dwarf planet. So currently we have 8 planets in the solar system. In our lifetimes, and maybe even the next few years, we might have a 9th planet again. There's that mysterious planet X, they're calling it. They think that's the planet that's much further out than Pluto, even I think another 5 to 8 times further out than Pluto. And it's the size of, they estimate the size of Neptune. And the way they can estimate that and how far out it is they look at the orbits of, let's say, Pluto or the other dwarf planets, Eris, Haumea, Makemake. They're out in the outer solar system, and we can plot those orbits and see how the orbits of those are disturbed from what our predictions are. And so the only way to disturb the orbit of something is through a gravitational tug. And so we can estimate by how much disturbance there is where that planet might be. And it's so far out that it's going to be really faint and really hard to find because it's not going to have much sunlight to reflect back to us. And so that's what's the problem and what's holding us up in finding it. But we might find it in the next few years. So this one here, I haven't given the name away of it yet. Sometimes we call it an evening star. Right now it's setting a little after the sun. So we call it an evening star, it's not a star, or a morning star if it rises before the sun. But that is going to be Venus right there in the southwest. Northwest. And if I fast forward time a little bit more, we should get one more planet. Might get behind that tree. Let's see if I can turn off the trees here. We should get one more. The labels up right there next to Venus. And we get Mars as well. So if you have clear skies in the next few nights, go out not long after sunset, maybe 20, 30 minutes after sunset, which you can look up sunset pretty easily, especially if you download this. You can click on a planet, and over here on the left, it'll give you all kinds of information. It'll tell you what time it rises, what time it sets. So I can actually quickly and simply in this program figure out what time, my last minute I can see Venus would be. So I know when to go outside and try to look for it. But again, there's going to be Venus and Mars kind of off to the northwest. The 2 brightest things, easy to spot, especially Venus will be the easiest thing to spot. All right, let's keep going forwards. I'm going to put our trees back up there. They're going to hide those planets, but that's okay. I'm just going to let it run, let more of our stars come out. I'm going to zoom out so we can see more of them as well. All right, we're not seeing too many, and that's because even though we're about almost 10:30 at night, my clock says, I have our light pollution turned on. I'm going to zoom out more. So we see kind of a handful of stars this direction, but I have all the light pollution turned on. And this is more of a modern problem than it used to be. So all the cities, they glow. You have lights in the cities, you have lights in buildings, parking garages, street lamps. They're all there for safety, but what they do is all the extra city lights that are on at night make the cities glow. And when they glow, they light up the nighttime sky and hide our stars. And we call this light pollution. And so it's more of a modern problem. It wasn't a problem before electricity, essentially. So if we want to see the nighttime sky that our ancestors saw every single night, what we can do is I'm going to go into my options here. I'm going to go into my sky, and there's a light pollution. I can turn it up or down. So how much light pollution there's going to be, I'm going to turn it down. Let's go all the way to nothing almost. There's our nighttime sky. So we can start looking around and almost see too many stars, really. If I look over here, now if you do live somewhere that's really far away from cities and the lights, all the light pollution, go out in the mountains or the desert, you can see our Milky Way glowing through here. So our Milky Way, we live in a spiral galaxy. Think of it, it's kind of like a frisbee shape or like a pancake shape. And so think of it like a pancake. So we're flat one way, but round the other. And so that's why we see stars as a band of light, like the Milky Way as a band of light across the sky and not everywhere. Is we're inside that pancake. And so, if you think of like, okay, if you want to look for chocolate chips throughout like a chocolate chip pancake and you're stuck in it, where do you look? You look through the batter to see more of them versus over here, you'll see less of the chocolate chips or the stars scattered throughout. So because our galaxy is kind of flat one direction, we only see this band of light in a portion of the sky. And it looks like if we look over to the east, Saturn rises up probably around 10 o'clock at night or so. If I keep fast forwarding, there's the star Vega. It's one of the brightest in the nighttime sky. I think it's in the top 3. I can't remember which number it is. But if I keep fast forwarding, there's Jupiter coming up probably around 10:45 or 11 o'clock at night, our time. You can see how fast it moves since we're running 1,000 times normal speed. Let's pause it here. There's a planet Uranus coming up. We're not going to get too much else until close to morning. There's Mercury coming up just before the sun right now. You can see off to the east, our sun's starting to come up. So you get a little bit of blue sky, like the light coming in. I'm going to hide that and turn that off. There we go. So we can see still a nighttime sky here. See, there's Capella, part of kind of this pentagon shape here, part of Orija, the constellation. There's this little question mark looking shape, that's the Pleiades. And then down here, this little V shape, that's the Hyades. So those are 2 star clusters that were all the stars in those clusters were formed at the same time. So all these stars in the Pleiades were formed together, and all these in the Hyades were formed together. There's our star Aldebaran, part of Taurus, the bull. There's the V shape for his horns. And I'll show off more constellations in a minute. There's a lot more this program can still do that we haven't even touched on. And so that's a quick, simple way to find like planets. And that's usually what you're gonna, if you see, a bright star, like a bright star, you think it's a star at night, go in here, you can figure out what it is. So if you think, oh, it was, I could find Jupiter and Saturn, it was a little bit upright, click on it, and it tells me it's Altair. And it gives me information about it. It's a pulsating variable star. It tells me the magnitude, how bright is it? The lower the number, the brighter the star. It tells me what time it rises, sets, and you can add more info here in the settings for the program. You can give it, have it tell you all kinds of things about it. I just have like a few small selections turned on. It tells us the distance to get to Altair. It's only 16 light years, well, almost 17. So that tells me that it's fairly close in the galaxy. If our galaxy is an estimated 100,000 light years across, well, 16 light years is not that far away. All right, well, there's a bit more we can do here because we haven't even seen any constellations yet. So I'm going to turn them on a little bit at a time if I can. Let's see, I'm going to go back to the north. I'm going to try to find the Big and Little Dipper. Let's see. Oh, I think I fast forward. I think where is the Big Dipper? He's going to be, I think, down here close to the horizon, unfortunately. You got fast forwarded just too much. Well, let's do the Little Dipper first. All right, there we go. So there's our North Star, that's Polaris. And I know that because it's about 37 degrees up above the horizon. That's because here in Norfolk, we're at a latitude of 37. And so that's one of the things they used to do with celestial navigation. If you can learn the constellations and what constellations are up, what time of year, and where they are in the sky, you can figure out what direction you're heading. And so the North Star here, the altitude or the angle that is above the horizon, that is your latitude. So if you go to the equator, this star is all the way down here at the horizon. If you go to the North Pole, it's all the way at the very top, directly above you. That's what makes it special, is it's almost directly above the Earth's North Pole. But at our latitude here in Norfolk, we're 37 degrees north. So I know this is about 37 degrees up. So I kind of knew what I was looking for. Well, I'm going to see if I can get the constellation for that one, if it'll do just that. Oh, it's going to do all of them. All right, let's leave them all up then. All right, so there's all of our constellations. So how do we know which one's which? That takes a lot of practice. This is kind of what you're supposed to imagine when you go outside at night. Kind of connect the dots, draw the shapes. The stories help you remember them, sorry. And then the planets wander through them throughout the course of months to years. That's why the planets are called planets. It's an old word that means wanderer. The planets over the course of weeks to months, as they move in their orbits and the Earth moves through its orbit, they move compared to the stars. So they wander compared to the background stars. And you got to imagine, this is what people sat around and did thousands of years ago. They didn't have TV, they didn't have radio, they didn't have internet, they didn't have books at one point. And what do you do to entertain yourself? Well, you sit around and you tell stories. And so you tell stories about the shapes and the constellations. And so that helps you not just pass time, but also start to predict time. So if you know, okay, let's see, this is Pisces right here. There's one fish. There's another. There's them like the stream of water as they jump out of the water. So that's Pisces. So if I know what time of year Pisces rises closer to sunset, then I can start to predict when the weather's going to change, because I know what time of year Pisces rises, or Orion, or whatever constellation you want to imagine. If you can remember that constellation in the sky, you can start to predict time before the calendar was ever invented. So now you know when the harvest needs to happen. And that was one of the big things for why these are important. I'm going to put some labels up for us, because I've been showing them off with no labels. So that helps a little bit. So if you don't sit outside every night and look at these, or if you don't work in a planetarium, how do I know this is Pisces? I mean, it's just because I work in a planetarium and I see them pretty much on a weekly basis that I've learned some of them. Some of them are really popular. Again, like there's the V shape for Taurus. So there's his horns extend all the way up. The V shape is really bright, really prominent. Aldebaran's one of the brightest stars in the nighttime sky. Another really easy one usually to find is Cassiopeia. It's a nice W shape. So that's Cassiopeia. Her husband was, King Cepheus. That was the king and queen of Ethiopia. They had a daughter, Andromeda, who eventually later on married Perseus, who fought Cetus, the sea monster. So these kind of all work together to tell a big story. And many of these do have multiple stories to them. So there are some minor, the Little Bear, the Little Dipper, and that curves down and towards the Big Dipper, which is kind of hidden by our trees right now. Let's see if I can turn that off. Let's see, Draco. Draco's a dragon. So there's the head of the dragon. He curves up and around. Ursa Minor. You probably recognize Hercules over here. But again, these are little abstract shapes, because we can't always draw exactly what we're trying to find by connecting the dots and the stars. how is like King Cepheus here? How is this what almost looks like, a child's portrait of a house? How does that make a person? Well, again, they're kind of abstract. You kind of work with what you can, but we can add pictures to them as well. So now we can see, oh, there he is. There's the person. There's Cygnus, the swan. It's for King Cygnus, who was turned into a swan. He was known for playing a lyre or a harp. So there's his lyra next to him. Let's see if our picture of Hercules down here. There he is. He's fighting the Hydra. So he's got several heads of the Hydra. If you remember your mythology, every time you cut the head off the Hydra, 2 more grow in its place. So he's kind of fighting one with 3 heads here in this drawing. There's Aquila, the eagle. That's the eagle that was kind of the messenger of Zeus. He would send it down off of Olympus Mons to either go kind of retrieve people or take messages down. Let's see if we go this way more with Zeus here. We've got Capricorn. So the front half is a goat. The back half is a fish. It's almost like a goat mermaid, which is really interesting. But these represent the upbringing of the childhood of Zeus. His childhood friend, because he was sent off away because his father Kronos, the Titan, would have killed him because of a prophecy about one of his children killing him. And so Zeus was sent off. And so one of his childhood friends was a goat, and he was raised by the sea nymphs, which are kind of like mermaids in today's lore. And so there's like the mermaid tail, and then there's the front half of the goat. So this Capricorn represents the upbringing of the childhood of Zeus. Some of them are a little more modern, like a microscopium here. It's literally a microscope. There it is. It's even down here, telescopium. It's a telescope. And the modern set I have turned on here was kind of put together in around like 1920s, between 1920 and 1930. And so there are 88 in the modern set. I mean, it's really interesting that throughout history, almost every society has constellations, no matter where you go. That's because the sky is ubiquitous all around the earth. And so everyone throughout history has pretty much sat around and told stories of the shapes in the sky. It's just the modern set consists mostly of ancient Greek and Roman mythology. They're the ones that really started the concept of studying astronomy as a science. And so they were also one of the largest civilizations throughout history. So many of their mythology and constellations have stuck around. And so there's kind of is the one that accounts for most of these. But again, there are a few others that are, a little more recent, like microscopes, or let's see if I can find it. Let's see. Fornax down here. Another one I always kind of like. Fornax, looking to the southeast there. It's a wood burning stove, and so it's important in the during certain times of year to stay warm. And so there's literally a stove out in the constellations. But again, most of them are ancient Greek and Roman. You might recognize Eridanus. This is a river. It's one of the rivers of souls in Hades. There were 3. The most famous one is the river Styx. You can even see that in their drawing here, they kind of have like little human silhouettes kind of flowing through the river of souls here. So I've looked kind of mostly at the northern hemisphere. But what's great about a program like this is we can go to the southern hemisphere, or if I just turn off the ground, I can then just look down. So I can see constellations that we'd never see in the northern hemisphere here. Puppis here, there is a ship. You can see the sail, and it's upside down right now, but you can see the sail for the ship is one we'd never see here in the northern hemisphere. So if you live in a different part of the world, well, you see different constellations. It's just because as the Earth rotates, we only see a portion of the sky. The Earth is in the way for much of it. But if you live in the southern hemisphere, you would never get to see Ursa Minor or the Little Bear or the Little Dipper. So no matter where you are, there's usually a portion of the sky you can't see. Now, if you do live at the equator, you do get equal portions of north and south. So you get a chance to kind of see all of it. But the further north or further south you live, closer to the poles, the less of the other half of the sky you see during the day, or sorry, during the night. All right, I don't want to spend too much time on constellations because this is something you can always turn on yourself if you download this program, and then kind of wander through it or go read up the mythology, because with 88 constellations and multiple stories per constellation, we could sit here for hours or days just talking about all the different mythologies here. So what I wanted to do instead was also show off some of the graphics of this program. So I'm going to turn off the constellations first. Oh, I guess before I move on to that, what's really nice about this software is if you're trying to learn the constellations, what you can do is I'm going to zoom in some, and let's pick Pisces here. And I'm going to turn up a little bit of light pollution to hide some of the stars. So simulate a little bit closer to what it's like living in, say, Norfolk or like Virginia Beach. Didn't hide too many. It's not hiding them for some reason. Not much. Okay. Well, that's okay. So what you can do is say you have the constellation lines turned on, and then you want to practice where these constellations are. So you want to find the shapes. So then all you got to do is just kind of look at it for a few seconds, try to memorize what stars it's using, and then turn the lines off. Can you still find it? And so you would, kind of start a little bit. Let's say you want to learn like just this part of Pisces first, and then you find this part here. So let's focus maybe like on these 5 stars. And then if I turn the lines off, can you still kind of see it with these 5 stars here? So then we kind of get like a little bit almost like a house shape, pentagon kind of thing here. Then our water comes down. So this is a good way to practice learning your constellations too, which I know we do have like Cub Scouts come out. We have to teach them a few constellations. They have to learn for one of their badges. They have to learn, I think, several different like specific stars like Spica or Aldebaran, Polaris, and then like about 10 or so constellations. They have to be able to spot them in a planetarium, and then go outside, like whenever they go, on like an overnight trip, also go out and be able to find them. So this is a great way to practice for that. All right, what I wanted to find next is, let's go over to, let's do Jupiter first here. So if I click on Jupiter, and then I can just use the mouse wheel in this and start zooming in. Oh, so we do have Neptune back here. Didn't see it a minute ago. And you see more and more stars, but it's almost like we're looking through a telescope at this point. So we're zoomed in, we're magnifying it, and you can start seeing some of the moons around Jupiter. So there's Callisto, Ganymede. That's either going to be Io or Europa. I'm not sure. Let's see, there's Io. Where's Europa? Maybe it's behind it. I'm not sure. Because there's 4 Galilean moons around Jupiter. Those are the ones Galileo first discovered 400 years ago that helped prove not everything has to orbit the Earth. Some things orbit other objects. So Io, Europa, Ganymede, and Callisto were our first clues in the early 1600s that objects can orbit something else besides the Earth. So Galileo found out, as he was watching these night by night, that they kept orbiting and like moving around Jupiter. Io goes around in about 2 days. I think Ganymede and Callisto go around in like about a week to 2 weeks. So they orbit quickly, but night by night you can see them and plot out how fast they go around. But if we keep zooming in, we can get a pretty good view of Jupiter here. So you can see the different cloud structure, the cloud bands on Jupiter. The white clouds, those are water vapor, just like we have here on Earth. So that tells us the temperature and pressure ranges for what must be there, because otherwise, if it's too hot or too cold, or the pressures aren't right, you can't form water vapor clouds. So that gives us a little bit of a hint of what the outer layers of Jupiter's atmosphere is like. The brownish red, it's ammonia hydrosulfide, just another type of molecule that can form clouds in the right temperature and pressure ranges. They do form at different elevations as well. So it tells us a little bit about the elevation on Jupiter by looking at the colors and knowing what they're made of. And you can see lots of circles, and those are storms. So I mentioned that I'm at home today because I was trying to beat the rain from a tropical storm coming through. Well, and that's from the Coriolis effect here on the Earth. As the Earth spins, it causes something called the Coriolis effect, which then can translate to the weather patterns and then helps form storms and hurricanes. Not so much like smaller storms like tornadoes. That's a little bit different process, but for hurricanes, that's one of our main processes that starts them. And so Jupiter, being a gas giant planet, it's almost entirely gas. There's probably a rocky core about the size of Earth, but that's 1/1,000,000th of the total volume. So that's a very, very small rocky core. The core could be a little bit bigger, a little bit smaller. We're not exactly sure. It's hard to probe something like this just because it's like hundreds of millions of miles away. And how do you probe something that you can only see so far into? The Juno probe is up there right now, and it's using radar mapping to look a few miles into the atmosphere of Jupiter. But still, how do you figure out what the interior is like? And that's hard to do. So we don't know exactly what the interior is like, though. But if this planet is huge. I mentioned the gas giant. When I say giant, I really mean it. You can fit about 1,000 Earths inside this. I think I said 1,000,000 earlier. Sorry, I'm thinking of the sun. You can fit about 1,000 Earths inside of Jupiter. And so it also rotates much faster than the Earth does too. A day here on the Earth, we all know, lasts right around 24 hours. It's not exact, but it's close to 24 hours. Well, on Jupiter, a day lasts about 9.5 hours. So it's much bigger than the Earth, rotating much faster. And when it's almost entirely made of gas, well, you have a very strong Coriolis effect and a lot of atmosphere to work with. You can make and sustain kind of the superstorms like the Great Red Spot, which I think is just hiding over here. I'm going to see if it will let me, if I start rewinding time. Oh, no, it's going to move Jupiter instead. Okay, I'm not actually locked on it. Let me see if I can lock on it. I don't remember exactly how to lock on. I know you can lock on and follow it, so you can watch it spin and rotate. I just don't remember that button from here. I'll be at the Great Red Spot over here. It's a superstorm, or kind of almost like a super hurricane on Jupiter. It's about the size of the Earth. It used to be bigger. We've known of it for 350 years or more, just because we've had telescopes big enough to see it for about 350 years. And then the storm, it's been there the entire time. It does move around the planet. It gets a little bit closer to the equator, a little bit further, but it usually stays in about the same latitude. And it has been shrinking for the past few hundred years. At the rate it's shrinking, it might possibly be gone in the next 20 to 30 years. We don't know, because we don't exactly know what is sustaining the storm, why it can stay there for hundreds or potentially even thousands of years. We don't understand that process yet. So at the rate it's shrinking, we say, it might be gone in 20 or 30 years, but since we don't understand the exact physics of what keeps it going, it might potentially shrink a little bit, stop, and then maybe it'll rebound and then get bigger again. We don't exactly know because we're still trying to learn a lot about it. All right, let's leave Jupiter. Let's see if we can go over to Saturn real quick. There we go. We start seeing some of the moons around Saturn. Saturn currently has the most moons we know of in the solar system. It has 82 moons. The next closest is Jupiter with 79, and some of those were just announced a couple of years ago. We're still finding moons around these planets, but since they're large and they have a lot of gravity, then they can kind of trap asteroids from the asteroid belt, kind of pull them out, or keep it, and they hold this many moons. All right, so there's a nice view of Saturn. In our lifetime, some of the really important moons to remember the names of, way over here to the left, there's Enceladus. That is close to the size of our moon, but I think it's smaller, but it's close. It's not just a few miles in size, it's hundreds of miles in size, but it has an icy shell and it's water ice on the surface, but below that is a liquid ocean. And that's what makes this one really important, is that liquid ocean underneath. So just like the moon Europa over around Jupiter, these two places, Enceladus and Europa, have the potential to harbor life if they have a liquid ocean underneath an icy surface. And what helps keep them liquid is as they travel around the planet, sometimes they're a little bit closer to the planet, sometimes a little bit further. And so that flexes the core, the rocky core of the planet. If that flexes it, well, then you have rocks rubbing against each other in the interior, and that keeps the interior warm. And so that warmth radiates out and keeps a liquid ocean, liquid until you get to the surface, then it's too cold and it refreezes. And so you have warm liquid water. So now you potentially have a place where you could harbor life. Another really important one, let me zoom out some because it's way out here. Here's Titan. Titan is the second largest moon in the solar system. It's bigger than the planet Mercury by just a few percent. But since it doesn't orbit the sun directly, it orbits a planet. It's considered a moon. That one is the only moon with a substantial atmosphere. And the atmosphere is mostly methane, so something we can't go breathe. So it's really cold there as well, because it's a billion miles or more from the sun. But with the methane in the atmosphere and being around the right temperature, the methane acts almost like water does here on the Earth, where it'll go into the atmosphere and then rain out and then form ponds or lakes on the surface. So now you have a place with liquids where maybe you could potentially harbor life. And methane does have carbon in it, so you kind of have some of the ingredients to potentially form life as well. So that could be some of the big places that we might see in the next couple of decades as being important, like Enceladus and Titan. There was talks of the program called Dragonfly from NASA. Dragonfly was going to put about the size of a car, put like a drone on there that could then fly around Titan, which we've seen the drone on Mars kind of flying around a little bit lately in the news as they're doing a few test flights, but do that here. So it goes fly somewhere, lands, uses solar panels to kind of power itself back up, sample maybe the lakes or the rocks, and then fly somewhere else and then drive around. So Dragonfly could be really kind of a breakthrough program in the next few decades if it comes around. And there's not just planets in this. I mean, you can see all the different stars. There are deep sky objects as well. There's a few thousand already pre-programmed in the software. If you go to, wrong one. If you go to, let's see, it's a configuration window. Yeah, plugins. You can go download more things. So you can download like other novae, meteor showers, pulsars, so that we can add more to the actual software itself. But there are deep sky objects. Let's see. So there's different clusters, different nebulas built in. Let's see, I'm trying to think of what's a good one. Let's see, the Dark Horse Nebula. I'm trying to think if that's one of the really good ones or not. Let's see. There's globular clusters. Those are clusters of tens to hundreds of thousands of stars that were all formed at the same time, and they orbit the exterior of the Milky Way. I'm going to look north because I know off to the north, the Great Globular Cluster in Hercules. I know that's a really good one. So if we start zooming in here, it does have pictures taken from telescopes built in as well. So this is a globular cluster that orbits the Milky Way, and we estimate 300,000 stars in this cluster. They were all formed at the same time from the same gas cloud. These clusters gave us the first idea of how old the universe really was. At the time, we knew the Earth was about 4 billion years old due to carbon dating and rocks, but we didn't really exactly have a good idea of how old the Milky Way was or how old the universe was, because this was 100 years ago or so. And as we started to use techniques and we understood more about stars, we could figure out this cluster was about 12 billion years old. Well, suddenly we knew the universe had to be at least 4 billion years to suddenly we say, okay, it has to be at least 12 billion years old. So these clusters have been really important to astronomy. I'm gonna go to the north a little bit here, because I know there's some good galaxies to the north. So let's see. Look and see if M82 and M81 is up. We'll just go to Bode's galaxy since it's labeled here. You see, as I zoom in, just more and more pictures start coming up. So this is a really fun program. If you get into like some kind of amateur astronomy, this software can actually even control your telescope. So what you can do is click on Bode's galaxy and then use controls up here to target your telescope at it. So this interacts with your telescopes as well. And you can go, if you have a camera set up on your telescope, you can either take pictures of it or remove the camera and try to look through it and see if you can see the galaxies as well. So it's a really fun, interesting tool that you can just download for free from home. While the cigar galaxy is up here, this is a really fun one. This is an interacting galaxy. So you have two galaxies merging together. The gravity of the two is pulling them together, and they are currently merging. It will take probably billions of years for them to merge. We call this galactic cannibalism. It's one of the best terms in astronomy. All right. And so since went a little bit longer than I kind of expected, just showing off the program, I think now might be a good time to see if there's any questions. We can start answering a few things. I know I mentioned an infrared camera, but I also want to make sure I have a chance for you all to ask questions. So let's see, what do we have? And if there's anything in the program, I can help, show off something else that maybe you had questions about.
Well, Justin, it looks like right now we had a couple of questions that we could answer that I just answered by typing the answers in. But there's one I've been saving because this person's obviously really enjoyed everything and wants to know if we can actually find some aliens with this software.
Oh, can we find aliens with the software? Unfortunately not, because we don't know where they are. And so and that's why this software, and I get questions like this all the time. If I mention, let's say, like during a planetarium show, I mentioned, there's, an exoplanet somewhere that potentially harbors life. Someone's like, can we just go look at it? Well, the problem with doing things like that is we don't see the exoplanets directly. And an exoplanet, in case you're not familiar with the term, that's a planet orbiting another star. So, we have 8 planets orbiting our sun, and there's hundreds of billions of other suns throughout the galaxy. And so there's likely to be other solar systems. And we're learning that most stars have between 1 and 2 planets on average. So that means some won't have any, some will have a lot, some will have just 1 or 2. But we don't usually see those planets directly. We see their effects on the star. We find them through indirect measurements. Only a couple, like maybe 2 or 3 other planets outside of our solar system around other stars have been imaged directly. Usually what we see is you look at a star and then you look for it to dim. As the planet travels in front of it, the star is going to get a little bit dimmer because the planet will block some of the light. And so you look for how often does the star dim, and so you know how often the planet is in front of the star. So we don't see the planet itself, we just see the star dimming periodically. And so we don't usually see the other, the planets, to let alone, look for life there. Now we have gotten really good at looking for other planets. We know of, I think 5,000 other planets throughout the galaxy so far, maybe more at this point. And I'm sure we'll learn of tens of thousands more in just the next few years alone, honestly. And we've gotten good techniques so we can even see what the atmospheres are like, what they're made of. But we can't see like the surface to go look for them. But we can still look for markers like, does the planet have water vapor in the atmosphere? Does it have oxygen? What's the temperature of the planet? We can look for a few things like that, but we've not found anything, anything definite about aliens, unfortunately, not yet.
Okay. Well, kind of a follow-up to that. And this was actually for me, now that we're talking about aliens.
Oh.
In the news, there's been a lot of news about UFOs and sightings and that type of thing. What's your take on that?
Oh, so UFOs and sightings, some of that is kind of like, I want to say the ghost effect. Like if someone says, oh, this house is haunted, and you go in and you hear a noise, you kind of say, oh, that must be the ghost. And so I think a lot of those, which don't get me wrong, there are a few sightings that do seem to be kind of unexplainable. Maybe we can get to that in just a second, but I think a lot of it's also the fact that you see something strange, maybe you don't know what it is, and so your first thought is, oh, it had to be a UFO, when maybe it could have just been an airplane or a drone. Especially nowadays, drones are getting really interesting, and like they're getting fast, and so at night you just see something fly by really quick. It's hard to tell how far away it is, and how close, so you can't really get a sense of scale of how big it is. And so they're going to probably add to a lot of sightings coming up. But I think it's that kind of effect where when someone says, oh, I saw this, so now it's on your mind, so you see something strange, and so you just kind of attribute it that it must have been a UFO as well. So I think a lot of sightings typically are something that can be explained. Maybe we just don't know it right away. But there are a few interesting cases out there where, like, fighter pilots, they've recorded chasing something. But that's also where sometimes, the government, maybe they don't want to mention that they have seen certain sightings because now they're seeing maybe drones or new testing technology for some type of airplane from another country. And they don't want to give away that they know that yet because they want to either develop something or at least be prepared. And so, I know there was the whole UFOs kind of got a lot of hype or mid to late June. I believe the Pentagon was releasing some information to Congress around that time. So there was kind of a huge uptick in the number of people talking just about UFOs because it was in the news. And so it's one where there are a few interesting cases. Maybe they can be explained, maybe not. But I think in general, most of them probably could be explained if we had a few more facts.
That sounds great. So another question he's asking, would you connect Stellarium on your computer to your telescope's motor housing?
Yes, and I think it's where, when you get up here in the top right, I believe, and let's see, there's a setting window here, so you can tell it like what eyepieces, lenses, and sensors you have, what telescope you're working with, and you can add more. And so, like, if let's say I click on, it's got a fun name, Swimming Alligator Cluster, and I click on it, it'll simulate kind of what, if I tell it what my telescope is, what the magnification's like, what sensor I have, it will zoom in and kind of show me about the area of the sky that my camera and telescope would take a picture of. And then I know in, let's see, the configuration window under plugins, there's telescope control. So you can go download a way to tell the program to run your telescope itself. So I did this with a different program as a graduate student. It was called The Sky. I think that program has kind of gone the way of the dinosaurs at this point. I think it kind of stopped being produced or updated around 2006 or maybe 2010. And so even that one's been kind of out of date for 10 years or so. So something like this, especially for like amateur astronomy, it would definitely be useful.
Great, that's awesome. So one person, we got two questions. One, he wants to know if you created this program, And two, if you could share your contact information, if you'll be willing to share your email, etc.
Oh, sure. Let's see if I can put my email in. Actually, my email is really simple. It's just the word planetarium@odu.edu. So maybe I can try to get that in the chat real quick. I don't know if we're actually sharing the chat or not, but I'll put it, but it's planetarium@odu.edu. That goes right to me. And then I didn't create the software or anything. This is because this started around the year 2000 or so. And so I was only 16 at the time. So it definitely wasn't me, but there is, see, Free Software Foundation. I don't know if they started it or they just currently have the license to it, but fsf.org. Or I believe just stellarium.org is the website. I'll see if I'm going to double check that one. Yeah, stellarium.org is the website for the software. Maybe I can share that window real quick. There we go. So here's the website itself. So you can go in and download it for Linux, Mac, Windows. There's a web version. So if you don't want to download it and install it, you can just use the web version. I find it's a little slower because it's trying to use your web browser kind of as the processor. So it's a little bit slower. So I find downloading it is much faster. But there's a user guide, there's news. So you can go through and there's discussions, a mailing list, there's documentation, there's all kinds of things that they still update this on a pretty regular basis.
That probably leads to the next question, Justin. He's asking, are there any limitations to this program that you'd change if you could? Kind of an interesting question.
Oh, stuff that I would change if I could. Oh, I don't know, because as far as working with, say, a kind of amateur, I'm gonna say amateur level, because this is still pretty advanced software. It's got a lot of capabilities already in it. I guess one thing I would change is it would be a big change to it. So it would take a lot of processing power. But let's say if I wanted to go to Saturn, well, rather than clicking on it and we can zoom in, there's a faster way to zoom in. See, that's going to center it up. And then if I get this right, this is that's the red. Yeah, if you're doing telescope, you can change it all red so it doesn't ruin your night vision. I don't remember what the fly to button is. There's a button that tells it just to fly to it. So I'm just going to zoom in. But instead of just, let's say, looking at it like this, what if I wanted to fly around it? So that becomes a whole different thing. Rather than just kind of projecting where things are in the sky, you now have to have a 3D model of the universe to fly around. And that's more what we do in a planetarium. So in our planetarium, we run a different software called Digistar. We have Digistar 7, which was just released less than a year ago, but it's a much more powerful program than this. So I can look at Saturn like this, but I can also take an Xbox controller, fly to Saturn, and then go around it, fly into the rings, look at the North Pole, go wherever I want. I can land on Saturn and look out, from Saturn's point of view and see the rest of the planets and what the constellations are like from Saturn, or see where the planets are from its point of view. So for this software, I think this is great for what it does. But I think flying around other planets and being able to go to different angles would be a really good addition.